In this tutorial, we're going to look at how to put an animated hero into our game and to use his position to trigger the loading of different rooms. Now, if you remember from a previous tutorial, we had created a class called Room that had a load room method which took in a room X and a room Y. So it's really just a matter of us triggering that method at the appropriate time from within our hero. Now, before we get into the code, I want to have a look at the layout of our sprite sheet, which you see here. Notice that the first row contains all of the animation for walking in different directions. In that first row, which is technically the 0th row, you can see the first two cells are the hero heading south, the second two are of him heading west, the third are of him heading north, and the fourth are of him heading east. The different colors that you see here represent the different levels of the character, with green being level 0, blue being level 1, and red level 2. So if we're clever about it, we can use variables in our code to determine where the source rectangle should be within the texture. And because of this, in the real world, you have to have a meaningful discussion with your artist about the layout of the assets. So let's go ahead and look at the code. Now this tutorial is going to be slightly different than the other tutorials because I've already coded up the solution, and the reason for this is because there was a fair amount of code in Hero that we're going to review here shortly. So the changes that have been made are in app main and also in Hero, like I said, and let's go ahead and look at app main. Now the first thing that you'll notice that's different is in line 15 and 16. This is code that's very similar to what you've seen in 1301, and essentially what we're trying to do is to determine how much time has elapsed since the last time that we called update. Alright, now if you drop down into initialize, you'll see starting at line 27, this is where we bring our hero to life. Our hero is a game object. So here in line 27, we load the link.png, which we just saw. In line 28, we're going to set that filter, which gives it that really grainy, blocky look. And then down here in 29 and 30 is where we create these temporary positions and velocities. We're not going to use a velocity again here in this game, but it's still nice to have. Finally, here in line 31, we bring the hero to life, passing him all of that stuff, and we'll dive into Hero in just a second. But I want to finish this part out, so if you look at line 33 and 34, we bring one of these stopwatches to life. And again, this is just for timing reasons. In 35 and 36, we set the current time and the last time to be whatever the time is currently. Okay? Now, we're going to create this variable called delta time, and what this is going to hold is the amount of time that has elapsed since the last frame. So look at how we do that. We get the current time from the clock. We figure out the delta time by subtracting the last time from the current time, and then finally we set the last time to be the current time, so it kind of resets that for the next time that we call update. Okay? And then finally we'll call hero update in line 44, and then down here in the render method, all we do is tell the hero to render. Okay, so a majority of the work is actually done in Hero, so let's jump over there real quick. Okay, a couple of things to notice here. If you understood that first discussion that we had about the sprite sheet, you can see that we have some constants that we've declared up, down, left, right, and these are nice so that we don't have to remember which way is down, which way is left. We have a readable variable here down as opposed to having to remember 0, 1, 2, and 3. Okay, we have a couple of different booleans. We're not going to use this one right here, line 22, but that's good in case you want to attack with your sword or attack with an arrow or something like that. We could determine that. In line 23, you can see that we've got a boolean called isWalking, and this is going to be important for our animation state, and we'll show you where we use that in just a second. We also have a heading, and these are one of the variables that we're using to calculate where we are within that sprite sheet. This one right here in line 25 is the animation rate, and this is how often we should update the sprite cell. In other words, how often we should move the cell throughout the sprite sheet. What this is saying is that every quarter second we're going to toggle between these different animation states. And you'll see the effects of that here shortly. Okay, we have a current frame, and that tells us also which cell that we're trying to access within the main texture. We have an animation counter that is going to be this aggregate timer that's going to sum up all of the time until it exceeds this animation rate, which we saw right here. And as soon as that happens, we're going to update the current frame. And again, we'll see that code in just a second. Number of frames of animation is going to be 2. We'll start the level out at 0, so he should be green when he first starts. Speed is kind of interesting because this is going to be the number of pixels that the hero moves per second. So I think it's going to be set to 150. Yes, it is actually in the constructor, and we'll use that in just a minute. And then possible update, we're going to potentially update the position. Later on, we're going to get into collision, so right now we're not going to use this possible update just yet. Okay? We still have a source rectangle, and we have the room X and room Y, which represents the current room that our hero is in. All right, now if we look at the basic layout of our hero, first of all, you can see that it inherits from GameObject. So we have all of those sprites and everything else that we defined there. And then we have a constructor that's very similar to everything else that we've seen previously. We set all of these variables up here. You can see that it's not attacking, not walking. The heading is initially left. The current frame is going to be 0. The speed is going to be 150 pixels per second across the screen. And then we set up the original source rectangle to be the upper left-hand one inside that main texture. Okay. We also have a sprite width, so we do some of that math like we saw in the tile class. Level is going to be 0. Maybe we'll change this just so you can see that it actually does work. And then the first room that our hero is going to be in is 7 over 0 down, which is in the bottom middle of the world that we're in. Okay. Now, the first thing that we'll look at here is update source rect, and this is where we use those variables to determine where the source rect is within this sprite sheet. So notice how we calculate that. I'm not going to get into the math, but notice that we say source rect.x, this is the upper left hand coordinate x, gets the heading, which is the direction, times the number of frames in the animation plus the current frame times 16. So you see we do a little bit of math here to determine the x position. And then the z position, which is the bottom right x coordinate, if you want to call it that, is just the source rect.x plus the tile size. If is attacking, we're not going to mess with that right now, but then we do the same thing with the y position for the upper left and the lower right position of this texture. So the last thing that we do is to update the texture coordinates, very similar to what we have seen before. Okay? Now, when we drop down to update, I've culled this down a little bit from a larger source. There's a fair amount of source code here, but let's go ahead and just walk through it and tell you generally what's happening. Now, here in line 81, you can see that we have this possible update. We're not going to be using that right now. We'll be using that when we talk about collision detections. But let's go ahead and drop down to line 83 through 86. Here you can see we're querying the gamepad to see which direction is being pressed currently. And I just have some variables here I created called moving left, moving right, up, down, and so on. Okay? Then what we do is to figure out how much time has elapsed in terms of seconds. And see how we do that. We go back to our main game variable, get the delta time that's happened, and then divide by 1,000 because we're working with milliseconds. Now look at how we use this second since last frame. Down here in the code you can see that we're updating the position based off of the amount of time that has passed multiplied by the speed, which is in pixels per second. Okay? The logic here is relatively straightforward. We can say if the character is moving up, then is walking is clearly going to be true, and the heading is going to go up. And similar kind of logic is used right here, so we'll skip past that for now. Okay? Now the actual magic goes on right here, starting in line 128. You can see that we're aggregating the amount of time that has passed inside of this variable called animation counter. And what we're doing is we're plus equaling the delta time into that animation counter. And as soon as the animation counter exceeds this threshold of 250 milliseconds, which is animation rate, then what we're going to do is to subtract that amount of time, the animation rate, out of the current animation counter. The reason is because imagine that the animation counter for some reason is at 300 milliseconds. We don't want to lose the 50 milliseconds difference between, if we had reset it at 0, we would have lost the 50 milliseconds. That's not what we want to do. Okay, so if the character is walking, which would have been triggered up here, then the current frame is going to increment, and then if the current frame exceeds the number of frames in animation, it kind of wraps back around. Then we call update source rectangle, which is the one that we just reviewed. And then dropping back down here, we can finally move the character around on the screen, changing the X position and so on, but look at what we do. We're bounds checking. If the X position of the character exceeds the main game.screen width, then we know that we've gone off the right side of the screen and it's time to load a new room. So what we'll do is increment our variable room X by 1, and then tell the main game to load a different room, passing it the player's room X and room Y variables. Then also notice that we reset the position of the character to be 0, which is going to position the character on the left side of the new room. We do similar kinds of things here with else if. You can see that we're doing similar kinds of bounds checking for the north side of the screen and the south side of the screen. And then the last thing that we do down here in line 165 is to update, and that calls the sprite position and rotation to update. So if I were to run this now, we should be able to walk around. It takes a second, it chugs at the very beginning, but you can see that I can walk over anything, but where it really gets important is when I go north, you can see that I can start to traverse the terrain here. Now notice we don't have any collision detection. That's okay, we'll solve that in the next tutorial, but it does work. We're actually loading different rooms and give this illusion that we have these really large terrains that are essentially just one room, and we're overriding that room data every single time. Okay, so that looks good for now. In the next tutorial we'll get into collision detection.